Back in the early 20th century, mathematics was on this amazing quest for absolute certainty. The dream was a perfect system that could prove every single truth out there. But then, this young logician, Gödel, came along and, well, he found something that would completely change our understanding of logic, of truth, and of the very limits of what we can ever know. All right, let's dive into this incredible story.
And look, that is not an exaggeration. Gödel's work wasn't just some small step forward, it was a seismic event. It was like he found a fundamental crack running right through the bedrock of logic, a discovery that literally shook the foundations of mathematics right down to its core.
So in this explainer, we're going to start with that big dream of a perfect system that mathematicians were chasing. Then we'll see exactly how Gödel shattered that dream, and we'll explore his two world-changing theorems. And finally, we'll look at how the shockwaves from his ideas are still being felt today, far, far beyond the world of pure math.
Okay, so let's set the stage. You have to picture the dawn of the 20th century. There was this incredible optimism in the air. Mathematicians genuinely believed they were on the verge of creating a perfect, unified system for all of mathematics. A system that could, in theory, answer any question you could ever ask it.
The tool they were going to use to build this was called a formal system. And really, at its heart, it's a pretty straightforward idea. You just start with a handful of basic, self-evident truths. Those are your axioms. And then you apply super strict rules of logic to them. The whole goal was to build this kind of machine, a logical engine, that could just churn out every single mathematical truth, one proven theorem at a time. Now, the champion of this whole quest was the brilliant mathematician David Hilbert, and his plan, which we call Hilbert's program, was unbelievably ambitious. Step 1, get all of math into one single formal system. Step 2, prove that system is complete, which just means it can prove or disprove any statement, nothing left unanswered. And step 3, prove it's consistent, meaning it will never ever contradict itself, like proving that 2 plus 2 is both 4 and 5. This was the blueprint for absolute certainty.
But this grand project was heading straight for what some have called the dramatic climax in the whole story of logic. And the main character in this climax was a quiet, absolutely brilliant Austrian logician named Kurt Gödel. He was about to find a fundamental, unavoidable flaw in the whole plan.
See, Gödel's work wasn't about finding some small mistake in the math. No, he was asking a much, much deeper question. He started to wonder, are truth and provability really the same thing? I mean, is it possible that some things could be absolutely true, but just forever beyond the reach of any formal proof? This is the question that changed everything.
And that brings us to Gödel's first incompleteness theorem. This is where he dives right into that gap, the gap between what is true and what a system can actually prove. So to really get what he found, imagine two different universes. One is the universe of truths. It contains every single mathematical statement that is true, period. The other, smaller universe is the reach of proof. It only contains the statements that a formal system can logically prove. What Gödel proved, with just staggering ingenuity, is that the universe of truths is always bigger than the reach of proof. There will always be true things that lie outside what any system can prove. So here's the kicker. It doesn't matter how powerful you make your logical machine. It doesn't matter how many axioms you add. If that system is consistent, it will also be incomplete. There will always be statements inside that system that are true, but that the system itself is just incapable of proving. It has a built-in blind spot. But Gödel wasn't done. Oh no. His second theorem delivered another, and you could argue, even more devastating blow to that quest for certainty. This one was all about a system's ability to look at itself. You see, part of Hilbert's dream was to use the system to prove its own reliability, its own consistency. But Gödel showed this was just impossible. A formal system can't use its own rules to prove that its own rules are sound. It creates this logical paradox. It's like trying to lift yourself off the ground by pulling on your own shoelaces. It just doesn't work. You need something outside the system to vouch for it.
And just like that, the dream of a self-contained, self-verifying mathematical universe, it was over. The conclusion was totally inescapable. The consistency of any system powerful enough to do basic arithmetic just has to be taken on faith. It can never, ever be proven from within. And there you have it. Gödel's two theorems, working together, just completely dismantled Hilbert's program. He showed that you can have a system that's consistent Or you can have one that's complete, but you can never, ever have a system that is both. The quest for absolute, provable certainty in mathematics had hit an unbreakable wall. As you can imagine, this discovery sent absolute shockwaves through the intellectual world. It triggered what's now known as a foundational crisis. But it wasn't just an ending. It was also a brand new beginning, with consequences that reached far beyond pure mathematics. After Gödel, the whole perception of mathematics had to change. It couldn't be seen as this closed, perfect, static set of rules anymore. Instead, it was revealed to be an open, evolving system, one that would always have new frontiers to explore because it has inherent, unavoidable limits. And his influence just spread like wildfire. In philosophy, it totally challenged our ideas about absolute knowledge. In computer science, it helped lay the groundwork for understanding the limits of what computers can even do. I mean, his ideas echo in physics, suggesting there might be no single theory of everything. And even in economics, where they touch on the very nature of choice. So let's just recap that shift, because it was massive. The dream, before Gödel, was all about absolute certainty, a single, closed system where every truth was, in theory, provable. The reality, after Gödel, is one of inescapable limits, an open, evolving field, and the humbling acceptance that some truths will always, always lie beyond our reach of proof. If you take away just one thing from all this, let it be this simple sentence. Not all truths can be proven. It sounds so simple, but its implications are just incredibly profound. Gödel showed us that the world of truth is infinitely richer and way more mysterious than the world of proof. And so we end right back where Gödel began. His work gave us a definitive yes to this question inside mathematics, but what it really does is open the door for us to wonder about it everywhere else. He revealed a fundamental limit to our logic, but in doing so, he opened up an absolutely infinite space for wonder.